It's 2 o'clock on the nose there, so I think we can get started. So just like to welcome everybody to the Learning and Education tracks programming for this afternoon. The plenary this morning was awesome. While you're all joining and stuff, just like to remind you all to update your name according to the naming convention that you see there. Please be respectful of everybody in the chat and keep your camera on if you're able to. We've got some really exciting talks and panels and discussion planned for everyone this afternoon, and we hope you enjoy it as much as we enjoyed putting it all together. But there's loads of other stuff going on at the conference, so please feel free to drift in and out and see everything that you wanted to get as much out of BioSummit as you can. So our first session in Learning Education track today is on our lightning talks in community bio teaching and learning. And these were all selected from members of the community that are doing some really exciting and innovative work in education, and they're split into 3 themes of curriculum, technology, inclusion, and culture. And we'll hear 4 speakers from each of them, followed by some time for questions. So please put any great burning questions that you've got in the chat box there. So without any further ado, we can start with our lightning talks on the subject of curriculum. We'll hear from Allison, McElroy, Yoshi, Goto, Annie Liu, and Sarah Canton. So Allison, the floor is yours.
Hi everyone, I'm Allison. I'm an artist and an educator. And through the years of teaching, I've noticed that the classroom really has a way of killing curiosity and independent thinking. So I decided to utilize Jacksonville State University's off-campus classroom. It is Little River Canyon, and it's a LEED certified building. It's the middle building. And the house is where students can spend the night. They're working right now on getting a hostel for the students. But you can see to the right is a site, 80-foot radius, that they've cleared for my class to do an earthwork. So the class I teach is art and science observations. And we begin with the historical timeline of earthworks. And we work throughout the semester of site prep, collection of materials, ideas, brainstorming, and then we get a plan for the earthwork. And next slide will show the most recent earthwork. The name of this earthwork is called the Compass, and the compass is based off of a Cherokee Indian tribe compass. We have the center, which is representative of the universe, and the students dug a trench around this, and then to the top of the page, north is water, and it is made up of a trench that ends in a small pool. And all of these objects were found on site. South, we have earth, which 7 chairs represent the 7 clans of the Cherokee tribes. Left, we have fire, where the students gathered controlled burned limbs and buried them upside down as representative of fire. And to the right, we have a handmade bamboo wind chime, as well as a wagon wheel half buried and turkey feathers hanging, so it shows the air blowing. So the students have a real love for outdoors, and I hope to really get them hooked on seeing the unseen and helping our environment.
That's awesome. Thank you, Allison. It's really cool. So we'll have some time for questions once we get through each little cycle of talks. So I'll move on now to Yoshi Goto.
Hi, everybody. Hi, my name is Yoshi from Sound.Biolab in Seattle, Washington. I'm going to see how fast I can get through this in 3 minutes. I want to share with you about our iGEM team at Sound.Biolab and a crash course that we developed in the process to empower high schoolers with confidence through education. So from 2017 to 19, Sound.Biolab ran a high school iGEM team, started initially by one of the SoundBio co-founders and a microbiology researcher. Just in 3 years, we impacted almost 60 students from over 10 schools with 5 advisors. Actually, one of our team members is here in the room, it's Eric. For those not familiar, the iGEM competition, which is an international genetically engineered machines competition, is an international student synthetic biology research and entrepreneurship competition. It encourages students to create local symbiotic solutions that create a positive impact in the world. So if you can click. So what is challenging about iGEM for high schoolers? So first of all, it was never designed for them. It was actually designed as a challenge for undergraduates and graduate students. Secondly, it requires multidisciplinary knowledge in a very cutting edge field, and you can't see this in the high school curricula. Third of all, iGEM forces teams to have real confidence, drive, and foresight to succeed in pursuing real novel research, thinking like a scientist, and engaging in scientific communication. So first of all, I don't think any of these issues are actually a challenge just in iGEM. These are challenges that any high schooler who wants to participate in biotech face, right? So second of all, how do you deal with this? I want to propose that it starts from establishing empowerment through confidence. And the confidence starts from purposeful education. Once students are confident, their passion and commitment can lead to really amazing results. So how do you build confidence through education? In the specific scenario that we have here, we decided to make a crash course to get students confident about synthetic biology. If you can go to the next slide. Okay. So we created a crash course focused on 3 main steps to get the team ready to tackle real novel synthetic biology research. It started from very basics. What is DNA? All the way to post-translation modification and plasmids. It also included literature review, which we felt was really lacking in most coursework that covers similar material. So complementing this crash course were hands-on activities to bring concepts to life. Ultimately, I'm really excited about this to ignite and satisfy the scientific passions of all these high school students. I hope that at the very least, it can inspire you and give you some ideas. While this crash course was created in a very purpose-driven way for the iGEM competition, I think that if we work on this a little bit more, we can have it be applicable to a lot of different groups. If you want to know more about this, let's continue the discussion on Slack. I'm also available on email. I know there's a lot of text here, so I'm going to post the slides on Slack as well later on. Thanks everybody for your time.
Thanks, Yoshi. That was cool. Next, we have Annie Liu from Princeton University.
Hi, everyone. I guess just to follow up on Yoshi, I was part of an iGEM team, so big fan, and you should really check it out. So my name is Annie. I'm an artist and an educator, and these are some of my wonderful students at various times, and I specialize in teaching critical design, tactical design, design fiction. So basically, my passion is in teaching students how to use the tools of science and technology, but to make artworks that kind of communicate the ethical, emotional, and social parameters of research, which I think is incredibly important. I work with all types of technologies, including wearable tech. I think a lot of the research right now is around AI, machine learning, computer vision, and surveillance. But in the domain of bioart and biodesign, we look a lot at gender rights, sexuality discourse, the history of reproductive science, biohacking, genetic engineering, synthetic biology, all of that. Next slide, please. And so these are some of the projects that some of the recent students have done recently. On the top right, you see hot girl glasses. I had a student who looked at AI algorithms that were judging, they were like AI-based beauty contests. And so she was looking at how she unpacked this algorithm and looked at what parameters they were looking at, how they normalize issues of gender. And she made these kind of like glasses that you could wear, and they would always give you a really high attraction score. I have another student, Joshua Zhao, right under that project, where he was looking at creating tools of empathy. And so he created this helmet that had a projector in which you could have a conversation with someone that you disagreed with while seeing the face as a different face. So could you kind of literally wear the skin of someone else in a way to try to kind of engender empathy. All the way on the left, you see a project by Kazula Kapolonis, and she was looking at surveillance, and she made this dress that would point to all of the surveillance cameras in public spaces. Anyway, a lot of projects that I'm super passionate about sharing. And if any of you are also teachers, I'd be really happy to connect on Slack. And like Yoshi said, I'll chat and email and everything. But yes, thanks everyone.
It's awesome. These are all so good. I'm really enjoying this. Thanks, Annie. Next up and last of our lightning talks on curriculum is Sarah Can.
Hello, everyone. Can you all hear me?
We got you.
Hello, everyone. Can you all hear me?
We got you loud and clear, Sarah.
Okay.
Can you hear me okay, Sarah?
I'm Sarah.
Go ahead, Sarah.
Hello.
Sorry, the floor is yours. The floor is yours, Sarah. We can all hear you great.
Okay, thank you. I'm Sarah Khan from Peshawar, Pakistan. I'm a strong believer of biology and have been advocating for bioart for the last couple of years. Since my last present here at the Global Community Bio Summit, I was really new to the community bio and bioart. So I started asking questions. How do I reach out to as many people as possible in my country? How do I enlighten and encourage them about the potential power of biology? And as art and design has a crucial role in science, I asked, how do I erase the existing boundaries between art and science? So as a synthetic biology researcher and an educator for quite a while now, I used 4 basic ways to promote biology as technology and integrating art and design in the upstream region of scientific research. So the first thing is teaching. I was offered to teach synthetic biology to the bachelor students at the Institute of Integrative Biosciences, and I blended that with entrepreneurship so that I can drive their attention towards building eco-friendly products with natural technology instead of just memorizing theory. I also teach at the School of Audacity, where we practically teach high school students about how biology is evolving rapidly, and that anyone can now read, write, and engineer DNA, which is unfortunately not taught through textbooks and traditional teachings or teachers. We've also organized events, collaborated with other like-minded organizations like ASM, participated in their AgriArt contest and also winning prizes. We also conducted and took part in exhibits necessarily for enlightening our people, for example, to at least be comfortable with bacteria, displaying bioart with concepts of art and design. I also kickstarted a startup with my team over here, only for the sake of spreading the biology to the corners of my country by providing them customized life sciences kits at their doorsteps. Next, please. Playing around with biology and studying nature deeply can also make a big difference. So we, the first ever BioArt community members that I created back in 2018, we do creative BioArt projects and organize events such as that we call breaking the boundaries for the local public. So we catalog numbers of insects and gotten inspired by their architecture and unique genes. We've also we've played a lot with bacterial chromoproteins and fluorescent molecules, making bioinks, biopaints, and dyes. My last project was Beit al-Ma'mur, done in collaboration with Joe Davis, which I think has also fantastically ignored the so-called lines between arts and science, delivering a beautiful message of hope wrapped around mathematical symmetry of the DNA. I don't see myself completely successful at all so far. Therefore, I'm all agog to learn from all of you. Thank you.
Thank you. Thanks, Sarah. That was awesome. Thanks so much to all of our speakers for curriculum. We've now got some time for Q&A. Does anyone have any questions? I know, hang on, I'm trying to open up the chat box. Oh dear.
If I can start reading out some of them if it's helpful.
Thanks, Amanda. Yeah, that'd be great.
Yeah. So Nell is asking specifically at Sarah, she'd love to know more about bacterial crystals for her STEAM girls.
I think that one's for you, Sarah. Did you hear that right?
Yep, sure. Can you hear me?
Yep.
Yeah, we got you.
Sure. So I created a method to, so I'm a painter myself, and I use a lot of oil paints and other acrylic paints. And I like all other people, I realized that paints are toxic and they have toxic chemicals used. So I thought, why not to create bacteria become our paints? So I used the method to crystallize them and later use them as a paint. So I dried them and killed them with UV and other stuff to make crystals out of them that you can clearly see in my slides.
Awesome. Thank you, Sarah. We have so many questions in just a little time, so I'm going to jump to a question for Yoshi. How do you deal with the learning diversity of students to work as a team in iGEM?
Yeah, so I just asked a clarifying question, and it's about
diversity
in the. No problem. It's about, just to clarify for everybody, it's about diversity in the range of background knowledge that students come in with. So it's a really good question, especially for high school, because some of the students that we worked with came in with basically no biology background. They haven't even taken high school biology yet. What I found is that, that's partially why the crash course that I developed starts from very, very basics of what is DNA, because not everybody has that fundamental. But I found that, of course, this learning has to happen through strong drive and passion. Some of the students who are 8th graders starting came in with no knowledge, were able to go through it, wanted to keep learning, and became some of our best student leaders. I also think that having that disparity allows for some leaders to stand up. People who are slightly older, maybe in their upperclassmen years, are actually able to mentor and help the younger students actually learn throughout the process of training and going through this crash course. So it allows for some creative, collaborative leadership structures to form. And I found that as long as you keep that in mind, you can actually create a really robust team structure despite the diversity in background information that students come with.
Awesome. So I think there are more questions in the chat, but we probably have to move on for time. So one question that I think everyone will want to be asking is, how do we stay in touch with you all?
I put my email in the attendance sheet, and also you can Slack me.
Great. All right. So we'll keep the conversation.
Yep, me too.
Okay, great. So we move on now to next section, which is on my kids aren't advancing, which is on technology. We'll hear from Data Ng, Sumeyye, Don Pinkerton, and Jim Rea. So Data, I'll give you the floor.
Okay, thank you, John. Can you hear me?
Yeah, got you loud and clear.
Okay,
mate.
yeah. And hi, my name is Data. I founded a biotech education startup called 2A Science in Hong Kong. Today, I will talk about how we modernize biotech teaching laboratory. Science teaching laboratory was formulated and doesn't change much since industrial revolutions. It's mainly using paper and pencil, blackboard, chalk, and no internet connected equipment. And one teacher usually deal with 20 to 30 students in a laboratory. Some students must be left behind. For 2A Science, we aim at providing hands-on driven biotech educations with latest biotech knowledge like CRISPR, plant-based meat, food science, bioart, bioinformatics, and bionics. We would like to inspire the student to enjoy biotech experiments rather than just reading the theory and all application cases in 20 years ago. We would like to make them feel biotech is the future and relevant to their life. To make biotech education easier, we have a few products. First, we built a biotech and STEM education kit, which contains essential operators with teaching materials for 30 experiments ranging from biotech, bioart, and bionics, and so on. It makes students and parents can even conduct biotech experiments at home. Next slide, please. John. Next one. Yeah, thank you.
Sorry.
Yeah. One of the major problems of one of the major problems of traditional science teaching laboratory is all in paper pencil. The teacher can only understand what students learned after the experiment class by reading their laboratory report. We would like to modernize and digitalize teaching laboratory. We are building hardware like a Juno for biotech to make the existing biotech equipment to connect to internet. Like we are modifying the pocket P-cell to connect to internet. Also, we are building an affordable and portable AI and IoT microscope. Although it's not a professional and research-grade microscope, but it is good enough, smart enough, and cheap enough for every student owning it. It can trace and monitor the change of the sample automatically. We aim at making it as around $40 USD dollars. It will be available in early 2021, and we will open source the design and software and everything so that everyone can build one. Also, we are making an app to control the equipment and as a digital laboratory manual and notebook so that the student can follow the experiment instruction in step by step and complete the laboratory reports. And at the same time, teachers can real-time monitor every student performance and give personalized help during the class. We also try to use AI chatbot to answer student frequently asked questions and give hints to them during experiments. And AI can also help teachers marking the laboratory report. We tested our prototype in Hong Kong and the feedback was so great. That's how we modernized biotech teaching laboratory in Hong Kong, and we would like to extend to other areas. Thank you.
Thanks, Data. Next up, we've got Don Pinkerton. No, we don't. It's Sumeyye. Sorry, Sumeyye.
Great. Hi, can you hear me?
Yeah, we got you.
Hi, everyone. I am Sumeyye. I'm joining from New York City. This is first time attending Biosummit. I'm so excited. I'm a molecular biologist by training, but I've been doing science education for the past few years. Currently, I am an educator at the DNA Learning Center of the Baltimore Harvard Laboratory and an instructor at Jacksonville, a community laboratory based in New York. My talk is not about high-tech, but low-tech frugal science tools. I want to raise the question of how science education may benefit from developing and using frugal science tools. I believe that frugal science tools can help us create a more universal, inclusive, and accessible educational curriculum that's easy to share and implement worldwide. I am imagining a world where we can teach from the comfort of our homes to students at the other side of the ocean without worrying about whether they have access to research tools or not. One classical example of frugal science tools, as many of you are already familiar with, is Foldscope, a paper microscope. A few years ago, when I was visiting my family in my home country, I packed some Foldscopes in my luggage, and when I arrived there, I was able to run a couple of microscopy workshops without really needing to have an access to a microscopy laboratory, and that was really easy. Currently, as a team, we are working on a project to put together a frugal biotech backpack. This is a project for Prakash's frugal science class. Maybe you heard about it. If you haven't, you should check it out. It's a great online class, open to everybody around the world. Right now, there are about 700 attendees from all over the world who came together to form teams in order to initiate projects and come up with frugal science research solutions. For our project, we're asking whether we can innovate and bring together frugal science tools necessary to run synthetic biology experiments. We're just starting, so things can change. But I still wanted to bring this up because if you're interested in this project, we would like to hear from you. Next slide, please. Thank you. Before I finish, I would like to talk to you about an educational frugal science tool that I made a while ago. I call it Microscope. It's a reinvention of an historic tool called camera lucida microscope. It helps users draw what they see under the microscope by directed tracing over the microscopic image. It does that by superimposing the image of the microscopic specimen with your drawing hand or the drawing surface, and you can see it in the GIF video on the slide. The GIF video shows exactly what you will see when you look through the lucidoscope, and you can see the hand tracing over the microscopic image. I made two prototypes. One of them is an adapter that goes on top of a trinocolor microscope. The other one is a DIY microscope, portable DIY microscope set. It's a standalone. Currently, the microscopes are either antique or the modern ones are very expensive. I think this is a very fun tool, and I believe that drawing really helps with learning. So I want to make this tool available and affordable for a broader audience. It's not out yet, but I'm hoping to get it out after a few more design improvements.
Sumeyye, that's great, but I think we're just out of time on that. But
yeah, I'm
if you've
actually
got links
done.
and stuff to. All right, sorry, Sumeyye.
Yeah.
Well, that's great. So I'm sure we've got loads of great questions for you in the chat. We can hear a bit more. Thank you,
Yeah.
Sumeyye. Next, we have Don Pinkerton.
Hi, everybody. Nice to see you. I just want to say, so my name's Don, and I'm an educator. I'm a biology teacher in Massachusetts. I primarily teach biology and biotech to students from underserved and underrepresented communities. So my real message is that I feel like we're in a position now to move students into real 21st century biology at this point. In other words, we need to move beyond just doing a strawberry DNA extraction for students. And I see there's more than two, but two necessary conditions for this to happen. You need a real commitment from educators. And then also you need partnerships with organizations, institutions, individuals that can help fill the opportunity gap that many underserved and underrepresented students face. So I just want to show the pictures on this slide on the right here represent some partnerships that I've been involved in. So for example, in this one, partners were my high school, MIT researchers, Mini PCR, the Whitehead Institute, Broad Institute, Illumina, Amgen, many others were involved in bringing this sort of science to students. I'd say the silver lining in the COVID cloud is that now we can really open things up. The technology is making these partnerships available really pretty much anywhere. And we're privileged to be here in Boston. We have tons of access, but I think this is going to open up. So if you could go to the next slide, please. So the picture on the top is a middle school summer camp that I'm involved in at the Whitehead Institute. And this year we went virtual. We're showing kids learning how to use pipettes here. And the partners in this were BioBuilder. I know Natalie's going to be speaking later, Mini PCR, and many other groups. And then on the bottom right, these were students I worked with, high school students I worked with at MIT. And we couldn't go on in the wet lab, so they were doing single cell sequencing data and analyzing that. But also I was able to bring in partners such as Justice came in and talked to our students, as did Xavier Palmer. So that was something that really opened up. So how does community bio get involved in this, and how can community bio help? I would say two ways come to mind. Community labs can really try to, and maker spaces can open up their offerings to students and teens. I know many do already. And then I know there are a lot of grad students and postdocs and PIs in this community, and they might consider getting involved in education outreach and exercising those broader impacts that a lot of funding brings. So I'm just going to close real quickly by just recalling the BioSummit statement of purpose, which is the last statement, and which is enabling local educators. And it's something that we can all do. And thank you very much.
Thanks, Don. It's really good. I love what you're doing there. Last up, we have Jim Ray.
Hey, can you hear me?
Yeah, got you, Jim.
Excellent. So I'm going to ask a couple questions. What if there was a synthetic biology club in every high school, and even most middle schools? What if high school IGM and biodesign teams were as common as robotics and coding clubs? So I'm Jim Ray. I'm the father of a teen Synbio enthusiast. Over the last 3 years, she's been able to learn to engineer yeast, to design plasmids, and now she's designing synthetic proteins. But without a lot of luck and support from some amazing folks in Amino Labs, none of this would have happened. And it made me realize that most students in middle school or high school simply don't get the opportunity to discover what biology can do. I think this is important because hands-on is the gateway drug to science. I'm a Cub Scout leader. I've seen firsthand that most of our youth come in thinking of biology as, unfortunately, the boring science. It's not cool to them like robotics because they've never been able to get hands-on and make stuff with it. So we could change the slide. This is a challenge because we don't give most high school students the experience of getting hands-on until grade 11 or 12 often. Yet through course selection, we're asking teens to commit to a biology track by the middle of grade 10. On the upper right of the slide, you'll see that of almost the 20 million students who register for high school each year in North America, just 70,000 go on to receive biology degrees. That's about 0.2%. And this isn't news. We want to see Synbio growing like Silicon Valley in the 70s. Are we producing enough minds to lead in this area? But also there's a human tragedy, because for youth, right now there are grade 7 and 8 students with a passion for biology, but they don't know it yet. And unless we're thinking younger about Synbio engagement, it's a passion they might never discover. What I find amazing about competitions like iGEM and the Biodesign Challenge is that they redefine perceptions of biology. DNA and proteins stop being abstract concepts and they become a three-dimensional coding language. They start viewing the cell as the ultimate makerspace. As amazing as iGEM is right now, it's also cost prohibitive to many schools. I've tried convincing a well-funded public high school to create an iGEM team, and the barrier was cost. Thinking younger means making these experiences accessible to all socioeconomic backgrounds. It's not impossible. Community labs can play a role. I've seen lots of great frugal ideas. Also, there's partnerships with industry for funding BSL-1 labs, biosafety training, iGEM teams at high schools. And what about broadcasters or Netflix? Can we get them involved by creating educational series for kids, inspiring youth to imagine themselves as biomakers and biocoders? So let's think younger in our engagement efforts. We want kids not just dreaming, but pioneering in Synbio. And that's me talk.
Thanks, Jim. Right on time. So we got some time for Q&A now. Amanda, would you help me out with the chat again, with the questions again?
Absolutely. And
Thanks.
we did have a question, if you could be sharing instead of speaker view as gallery view so people can see their faces.
Sure.
I'll leave that up to you to decide. So there was a lot of conversation going on during those while people are formulating their questions now. One that came up is sort of the disparity between, you know, 4th graders who are bored with the strawberry experiment versus 9th graders who have never done it before. So how do we sort of reach the diversity, the plurality of folks in education and the experiences that they're going to have?
Well, maybe I can speak to that. I think it's obviously a true thing that's happening. There is absolutely that disparity. I think the only answer I can really think of is to try to move this stuff into the elementary levels. I think a lot of kids are getting into, like at young ages, they're getting into robotics because they play with Legos and they're getting into all these other things. Jim's talked about this a lot. He and I had a great conversation around this about trying to get students and young people involved earlier and getting them excited about biology earlier so that they're able to take advantage of this. Jim, I don't know if you wanted to, I didn't want to steal your thunder there, but I know that's exactly what we talked about.
That's just it. I mean, you have to be, we're privileged, you know, we're not 1%ers, but without a lot of luck and some investment, it wouldn't be happening. Kids deserve to discover how cool biology is.
I love that. If there are any other questions, you can add them to the chat. I think we have another minute. Data is sort of synthesizing for us. In addition to a handbook to start Synbio, we need a GitHub for science, biotech, so that it's easy for beginners, students. And I heard that some folks already have ideas about that. But we're getting some questions now. Oh, go ahead.
I was just going to add, if you are interested in getting involved in education outreach, I would encourage you to work with actual teachers. There's a lot of groups who want to do education outreach, but unfortunately they don't know how to navigate like the public school and education space and talk to students for real life. So, you know, talk to people who do it, and that helps a lot personally.
Excellent. So I think, Mackenzie, how are we doing on time?
1 minute, 30 seconds left. So we could probably take one question.
So this is a question for Jim. How do you think we can get younger kids interested in bio? Because what interests a high schooler is not going to interest a 4th grader.
My daughter brought up a big good point at the panel last year. She said there's no kids shows about biology. You know, there's coding TV shows, there's robotics TV shows. How about shows that show what biology can do? Let's let's get kids grade 2, 3, 4 thinking, hey, this is something I can do.
Yeah, definitely media is going to play a big role there. Let's see if we have any other questions. I think there's been an active conversation sort of moving to the Slack. So if you're interested in carrying this on, some people have already sort of started that. I think Data and Yoshi, for example. Okay, so we might be a little ahead of schedule unless anyone wants to plug one last question.
I think I can add on Jim's answers. I think we could bring up something in our real life about synthetic biology, like CRISPR. There's the Nobel Prize winners. Some students may be interested about what is CRISPR, so that we could use the latest biotech and the biotech in real life to inspire the student, even they don't have enough knowledge or very advanced ones. I think inspiring is much more important than the knowledge.
I love that point. So getting back to the storytelling idea that Marshall Gans was pointing out. All right, so that's all the time we have. Thank you guys so much, and I'll pass it back to John for our third segment.
Thanks, Amanda. Yeah, thanks to all the speakers on great questions and discussion we're having. So next we've got our section on inclusion and culture, where we hear from Foad, Hamidi, Latasha, Wright, Nora, Jameson, and Paola, Larrauri. And I'll hand it over to Foad to begin with.
Hi, everyone. My name is Foad Hamidi, and I'm an assistant professor in information systems in University of Maryland, Baltimore County. I'm glad to be joining you all. I'd like to tell you about this bio-design project called Rafiq, which in Farsi and Arabic means companion or buddy. And this was a system I designed for children with and without disabilities to encourage them to complete therapeutic and learning activities in the home setting. And the idea was to combine a living and actually edible oyster mushroom colony with a networked irrigation system, and essentially to encourage children to complete these activities. Big question is, why did I choose oyster mushrooms? Because they're safe, they grow relatively quickly, so over a period of days as opposed to weeks or months. And also their growth can be to some extent controlled by amount of moisture or water that's given. Next slide, please. All right, so the way the system works is pretty straightforward. The more it basically monitors the digital activities that the children are doing, and it provides water to the mushroom. So it kind of basically they're controlling the speed of the growth of the mushroom. I designed the system basically by getting inspiration from children. A lot of the children I talked to, they had pets or plants that they were very fond of. So designing a toy for young children, I'm talking between the ages of 5 and 9, is pretty challenging. But I mean, a good way is talking to them and kind of translating that into a design process. What we found in studies in the home setting is that the children communicated with each other more and with their family more, and also completed more activities when the system was present. Fun fact, when the mushrooms were grown in every household, actually this happened in the few that I did case studies at, they were harvested and one of the parents ate them. In all cases, it was the father. I don't know if there's any significance to that. So yeah, that's all I'd like to share about this project, and I'm happy to answer questions afterwards. Thank you.
Thanks, Foad. I really love this bit of project. Next, we have Latasha, who, and I'm zooming through your slides. Sorry, Latasha, take it away.
Hello, everyone. My name is Latasha. I work at BioBus. So BioBus is a nonprofit organization located in New York City, where students can come to discover, explore, and pursue science. And we have 2 mobile labs that can travel all over New York City. And pre-COVID, we had 35,000 kids come aboard the BioBus to do hands-on explorations with us. And we also have a community labs that's located in Columbia Zuckerman Institute, where students can come and do after-school programs, weekend programs, and we also host public events for families. In addition, we also have high school and college interns. And then COVID hit, and then we had a little crisis about who are we, what do we do? And so we had to redefine what we were doing. But we really wanted to make sure that we sustained high quality of engagement of students and that we built an inclusive scientific community and made sure that the student voice is the guiding light of all of our curriculum development, and that if it was in person or remote, we still had high impact and personal interactions with the scientists. And we also made sure that there was some hands-on activities that could happen. Next slide, please. This is our COVID. So what did we do? All of our scientists now have microscopes at their house that I'm not sure I'm giving back. But we then Zoom into classrooms and we do experiments together. And then we also have weekly science challenges that are launched. And Tessa, she's also here. She's a BioBus person. She's also at this conference. So we have these challenges, and the kids can do these things with their family. It's normally with things that you can find around the house to do these weekly science challenges. And then they can send their results back to us, and then we send out a newsletter. And we also host weekly student town halls. And these, the subjects of the town halls are really student driven. So we've had things from racism to COVID-19 to dragonflies. But the ultimate goal is that we want to make sure that BioBus is creating a transformative, Tessa's talking, a transformative experience for all of the students.
There you are. Thanks, Latasha. I loved it. Really loved it. I want a BioBus in here in Newcastle. And I've lost myself. I was enjoying that too much. Next up, we have Nora. If I can advance the slides.
Sweet.
Here we
Can
go.
you hear me?
Got you, Nora.
Awesome. My name's Nora. I use they, them pronouns. I am a teacher at a community college outside of Portland, Oregon, and I'm currently developing a syllabus on science and social justice. It's an anthropology course that I'm hoping will be accessible to junior, senior level high school students and anyone who goes to community college. So some of the things that the course touches on is sort of the introduction of objectivity in science and sort of how that's a false notion in a lot of ways. And we're gonna sort of deconstruct from starting there, basically Western science and the notion of objectivity. And then we're gonna talk about different types of knowledge. So like outside of academic labs and institutions, what does other type of knowledge look like? So that's one of the examples that we'll be doing, is looking at Indigenous knowledge and movie screenings that are documentaries of Indigenous knowledge. So that's one of the things that the course will include. On top of that, it's a lot of going over racism and different types of oppression that intersects with science. So like eugenics is a huge portion of science that is sort of glossed over or just not talked about at all in a lot of ways. So the goal of the course is to educate people to be good, mindful scientists in a way that makes them think outside of the scientific method. There are other ways to think about science other than using the scientific method. So scientific method, you supposedly remove all your biases and start with nothing. The feminist method of investigation, you critically assess your biases and move forward from there. So there's different ways to approach science, and that's sort of what I want to teach people with this class, and sort of give an overview of how it's been done wrong. LIT is working with social justice mindframe in doing volunteer work as a part of courses. So that's the other thing in my class that's really important, is doing volunteer work with the students, but making sure that they engage outside of the class.
Paola.
Okay, thank you. Well, I'm Paola Larrauri. I'm a molecular biologist and STEM education promoter. And now I'm going to talk to you about Serendipity. In Peru, students and professionals in STEM careers face many difficulties in accessing training or postgraduate studies. So this translates to a small number of highly trained scientists. So Serendipity seeks to address this problem through a mentoring platform that identifies and trains the best STEM career students to become stronger candidates when applying for those opportunities. Some of the issues we've focused on is because a lot of student satisfaction with one-to-one time with professors at the university comes through normal or bad. And also it happens the same with their research opportunities in their universities. But this, I mean the infrastructure, the access to lab equipment, materials, regions, field tools, etc. So Serendipity seeks to address this problem through a mentoring platform, as I mentioned before, and during the semester, the selected cohort receives transversal workshops on academic and scientific tools to be able to enhance their skills and recognize their weaknesses and design strategies to strengthen them. So this training is complemented by one-to-one mentoring too. Can you go to the next, please? The next slide, thank you. Yes, thank you. So we have a lot of studies for a lot of regions or provinces from Peru, not just Lima. And the satisfaction about the program is really high. There you can see some photos of our students that have reached some scholarships outside or postgraduate programs. And well, in case you're interested in knowing more about this and also be a mentor, maybe you can contact me by Slack or around here. Thank you very much.
Great, thanks, Paola. That's the last one of our talks. We have some time now for Q&A. I'm going to stop sharing my screen so we can see everyone's faces properly. Amanda, would you be able to help me with some questions? Because
absolutely. So that was, there was a lot of conversation generated in the chat during those
I couldn't keep
talks.
up.
Really excited to see so many folks interested in the social justice angles. So someone asked early on to Foad, and then maybe it would be actually a general question to all of the speakers. Someone was wondering specifically what kind of disability are you working with in your learners? And maybe we could open that up so anyone could sort of talk about the sort of different populations that they work with and maybe the different considerations that come up when you're working with those populations in science ed. So I'll go ahead and let the speakers take it away.
Yeah, so with the Rafiq project specifically, I was working with children who have autism or other communication disorders. And part of the motivation for that was that we wanted to basically create an ambient system that engages them in the home setting. And so this data visualization, or I call it mushroomization of their activities through this interface, was the idea that it would kind of create some more dynamics for engaging them.
I'll chime in. As a community college teacher, I get students who are in high school to students that are older than me with a variety of different learning backgrounds and learning styles. One of the things that I think is important that I don't get to do in my chemistry classes that I teach is have discussion, which is something my anthropology course will have, including like smaller breakout groups. I think, as Marshall Gans was talking about, storytelling is hugely accessible way to make connections and make memories, as well as, you know, discovering our values. We also will discover how we critically think about things differently from other folks. It's more about, yeah. So I think letting people have discussions and then letting them have stories around the different topics that we'll be talking about will be vital, especially in such topics like social justice.
Amazing.
Oh yeah.
Go ahead.
Sorry. We work with K-12 students and underrepresented communities. I think the important part is to really create a safe space where we can foster the curiosity of the students, and also like stepping away from your own ego and being able to allow them to like lead where the discussion is going to go. And all of our curriculum is really made by students for students, because like what you think is cool is not what the student is going to think is cool 9 times out of 10. And they'll have better ideas than you, and they can iterate on your ideas if you just let them.
Very wise words to end on, I think, because we're about at time. And I know we want to make sure that we get a family photo before we all sign off. So I'll let John coordinate that. So short people walk to the front.
So yeah, virtually walk to the front. I think if I put everyone on gallery view, make my screen really big, I'll take some screenshots. So everyone wear a funny hat, put on your biggest smile, and say Bio Summit.
Bio Summit.
While I get my screenshotting apparatus.
1, 2, 3. Bio Summit.
Bio Summit.